So for the second part of video homework, let's talk about problem 2 in homework 8. So in problem 2, we have a Poisson process with parameter lambda. So we have the probability of the number of random points in T1, T2 equals k is e to the minus lambda T2 minus T1 k lambda T2 minus T1 k. Right, so this is the definition, or this is the probability of the Poisson process. So, and we define a new stochastic process as xt equals 1 if n is right here. This is n. Let's use another color. This is n. So if n is odd in 0 to t, and xt equals minus 1 if n is even in 0 to t. Right, okay, so here we go. We just jump to the question. The first question is we need to find the probability of xt equals 1, which means we need to find the probability of n to be odd in 0 to 2. So how do we do that? So we know that for a probability xt to be 1, it is the sum of k is odd, right? And the e to the minus lambda t, the k. So it's a sum of all the possible situations that k is odd, right? So this is like, let's write it, let's open this sum. It's 1 e to the minus lambda t and the lambda t plus. So all the odd k can be 1, 3, 5, and so on, right? So we know that it's lambda t to 3, it's lambda t to 5, and so on, blah 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 blah. So how do we get the result of this part? We can find another formula like this. We know that e to the lambda t can be written as another function, or another way. It's e times e plus is 1 plus lambda t plus 2 lambda t 2 plus 3 lambda t to 3, and so on. And e to the minus lambda t is 1 minus lambda t plus, right, because this is a square, so the minus here is a plus. So for all the even k, the signal here, this should be plus, right? So for the odd k, it should be minus. So if we use e to the lambda t to minus e to the minus lambda t, right, we can get, what do we get? We can get 2 times the lambda t right. We can get all the odd part, all the odd k, all the part related to the odd k here. So this is what we need for this function, right? So then it became easy. The probability of xt to be 1 is e to the minus lambda t times e to the lambda t minus e to the minus lambda t over 2. And this is 1 minus e to the minus 2 lambda t, right? And the next question, Question B. We need to find the expectation of xt. So, as the same, we know that if we want to find the expectation of xt, we need to find the probability of the two situation, right? The two situation should be the xt equals 1 and xt equals minus 1, right? So we have xt equals 1. We have the probability of xt equals 1 right now, but we need the probability of xt to be minus 1. So, and it's also the same. The probability of xt to be minus 1 should be 1 plus e to the minus 2 lambda t. Yeah, all the process to get this result is the same as question A, so I just skip it. So, okay. And right now we need to calculate the expectation of xt. So we use the value of xt1 to times the probability of xt to be this value 1, and the value minus 1, oh, this is plus minus 1 to times the probability of xt to be minus 1. Right, so it's easy. It's 1 minus e to the minus 2 lambda t plus 1 minus 1 plus e to the minus 2 lambda t. Okay, so what do we got? We have 1 over 2 minus 1 e to the minus 2 lambda t minus 1 over 2 minus e to the minus 2 lambda t over 2. Okay, this is minus e to the minus 2 lambda t. Right. So this is the answer to question B. And the question C. So question C, we need to find the correlation between T1 and T2. So correlation of T1 and T2 equals the expectation of xt1 and xt2. So, okay, there should be two situations for this. Wait a moment. For this event here, there should be two situations, which is 1 and minus 1, right? And if we want it to be 1, there could be another two situations. xt1 is 1, xt1, t2 is 1, xt1 is minus 1, and xt2 is minus 1, right? And if we want this to be a minus 1, there are also two situations. xt1 is 1, xt2 is minus 1, xt1 is minus 1, and xt2 is 1. So, as the same for the question B, we need to have the probability of this fourth situation here, right? But after some thoughts, we can find that this fourth situation can be separated to 2, right? Because in this situation, in the xt1 times xt2 equals 1 situation, we can see that it's all related to k equals even in T1 and T2, right? And for another situation, xt1 and xt2 to be -1, k is odd in T1 and T2. So this is very obvious, right? Because so no matter which situation this is, let's take this for example. If xt1 is 1, which means that n T1 is odd, and xt2 is 1, and T1 and T2 is odd. And for odd value to minus another odd value, the result should be even, right? So in this situation here, in xt1 times xt2 to be 1 situation, k should be even, and for xt1 and xt2 to be -1 situation, k should be odd. So this became much easier because now we have a correlation of T1 and T2 is is 1 times 2 over 1 plus e to the -2 lambda, and the t right now is T2 minus T1, right? And the plus -1 times 1 minus e to the -2 lambda T2 minus T1. The result should be e to the -2 lambda T2 minus T1, right? And the next question, question D. So in question D, we are asked to prove if xt is WSS. So there are two conditions in WSS, which is the expectation of xt should be a constant, and the correlation of T1 and T2 should be related to correlation of tau, and the tau equals T2 minus T1. Okay, so right now we can see that the expectation of xt is minus e to the 2 lambda t, and this is definitely not a constant, so it's not WSS. So that's all about the video homework.